Okay, so we'll continue with our bank account example, and this is going to be about inheritance. We'll dive into inheritance. So what we did in our last class is we wrote code from the scratch for all these different classes. Like we have current account, we have a default bank account, we have a different current account, we have a credit card. These things were implemented in our, the credit card was implemented in a lab session. Okay. I wrote code for that, and you can see that in the code that I just pulled. So we have this credit card where we have redefined our withdraw or deposit method. We have a current account where we have redefined the withdraw method, but everything else is the same. It's just the same as this bank account. So in today's class, what we're going to see is how we can use the concept of inheritance to get all the common stuff so that we don't have to rewrite. Okay? So we are pretty much going to reuse our code, and that's the essence of inheritance. We're going to look into that. That's the topic. So I'll dive into that, but before we get started, let me just tell you ahead of time. I may have a visitor coming in at around 10:30, so I'll need like 10 to 15 minutes. He's our chief coordinator, so we may have to spend some time together to talk about room allocation and other stuff. But that's a different story. It's just that I'll need a small break for that. Wanted you to know. So we're learning some basic object-oriented programming concepts over here. What we have already covered is called encapsulation, and today we're going to talk about inheritance. But another very important concept in OOP, which comes for free, is called abstraction. We should know about that as well. I think I didn't cover that yet, but let me list this out. The concepts that we are talking about over here. Okay, we'll talk about this as well, and further down the line we'll talk about something called polymorphism. Okay, but that's a difficult one, and we will leave it for later on. Abstraction is not too difficult to understand. Okay. We are using this even without knowing that this is the concept. The idea of abstraction is simply hiding the details. You don't need to know what goes behind the scene unless you're really bothered about it. So, if you look at this particular example, see, as a user of this bank account data type, if someone else have created this data type for bank account or credit card or savings account, do we really need to know the detail about how the deposit method works, how the withdrawal method works? Do we need to know that? The internal working. Like, let me give you a even simpler example. When you're learning C, you know to print hello world, you need to call the printf method. But do you know how printf internally does that? Was that necessary for you to know to print something on the screen? Did you need to know the inner working of printf to use that? The inner detail of that was not necessary for us. We just knew that we had to call this method. Even over here, if you look at the print method, if you go into the bank account data type, there is this print method, right? Where we are using this printf call. So if I ask you how this printf works, well, maybe you wouldn't be able to answer. I mean, we do know that we have to give a format specifier, we have to pass in the parameters, then it prints. Yes, that's fine. That's how we call it. But how this method works internally, we don't know yet. Okay? In Java, you can actually find it out, how this method works. Let me just show you. So you can just right-click over here, and you say navigate, go to source. It will take you to the source code of this thing. And you see now that it calls a printf method that in turn calls another method called format. So, well, we don't know what format is, so let us just dive into it. Go to source, and now it says format. So now we have something we haven't seen before, something called synchronize, which I'm not even going to cover in this course. we have ensure open, we have a formatter. All these things are a lot more complicated than meets the eye. So in essence, like, let us go back to the problem at hand, that in this bank account demo, just to call this print method, yeah, this one prints using system.out.printf. But we don't really know the inner working of it. That's much more involved. We were given this thing by the Java library, and we can freely call this thing. By freely, I mean that without knowing the inner detail. Okay? The detail of this thing is hidden to us, so we don't really need to understand how this print stream work, how this ensure open, the formatter, and the synchronize, all these things, they work. We know nothing about that. However, we are still able to print this thing with the printf call. And that, in essence, is abstraction. We don't have to know the detail about something to work with it. You just call that, and it works. Okay? And this is what makes programming possible for us, because if you were to worry about each and everything, each and every method that you call, then programming would be a very difficult task. You don't have to do that. It's already there for you. Let us give some example from real life scenario, and this is very much common. Like, I don't know how to drive a car, okay, but I know how to ride one, right? You can open the door, I can get inside. Someone else drives the car. Even he probably doesn't know how the engine works. He can still drive the car, knowing that the engine would work, and then he can drive. When we get up on the elevator, yes, we have learned that in physics, that there is a pulley system that pulls it up. Okay, but when you press the button, do you really think about how the pulley is working? Probably not. You're either talking to your friend or minding your own business, listening to music. So you're not even bothered about that in real life. Okay? And if I ask you, how many of you can cook?
Some items.
Some items, sorry. Yeah, some items over here as well. Not everything, but some items. Many of us maybe don't even know that. Okay? But does it stop us from eating? We have mastered that art already, right? We know how to eat, even if you don't know how to cook. So that's again another level of abstraction, because someone prepares the food for you, you know how to eat, you don't have to bother about how your internal digestion system is working, how your teeth is working, how your tongue is working. You don't have to bother about that. Because if you started to do that, you'd go insane. Okay? So that's again abstraction. And in OOP, we have this thing. You can write a method. What goes inside the method, you don't have to know. The user of this method doesn't have to know. So that's a very easy concept to wrap your head around. We have talked about encapsulation before, and this is abstraction. We'll move into inheritance today. Just wanted to make sure that we have these two covered. Encapsulation ensures that your data is secure. Abstraction ensures that the detail is hidden. You don't have to worry about it. And inheritance ensures that you reuse your code. You don't have to write a whole lot. Okay. So let me show you how this is done. Let us do one thing at a time. Let's say we have this basic bank account, right? And let us look at the diagram, the class diagram rather, UML class diagram. We have bank account and we have this current account, right? And this is pretty much a copy of this bank account. Okay? We're copy pasting everything. Now, what would be nice, right, as a programmer to know that all these things don't need to be copied over. You don't have to copy and paste everything, because if you do so, then any change that you make over here will not be reflected. Maintaining the code itself becomes a difficult task, because there will be changes going on into the bank account, and these things will not get auto-updated, so you'd have to spend more time doing that. So let me create a new data type, and for convenience and just to relate, I will give it a bad name. I will call it current account 2. Okay, and this is going to be a very bad practice. We don't usually do that. This is just to show you that this is actually the same thing. So I will create this new type, and for now I will call this current account 2. What we will do over here is use generalization or class inheritance. So this current account 2 is going to be a subclass of current account, and we show that. See, the way I drag this arrow is from here to there, but it still points the other way around. And this is how we show inheritance. It goes from bottom to top. Okay. In your exam, you'll probably be asked to draw UML class diagrams, or you may be given UML class diagrams, so you have to write some code for that. Make sure that you understand this right, that in inheritance, it always goes from the subclass to the base class or the superclass, from bottom to top. It points that way. So what happens over here, it still looks the same. Actually, it doesn't have to. You see, all these things, all these attributes are already there. So you don't have to bring them again. Okay. Okay, so we're not going to rewrite these attributes because we can use them from this class. We don't have to copy them over. And again, the only thing that changes in this current account, as you may have noticed, going from bank account to the current account, the only thing that changes is the withdraw method where we deal with this 15 type. Okay. So right over here, except for the withdraw method, you don't really have to bring anything new. Everything is already taken care of. Okay, you do need the constructor, and the name of the constructor is this. And this was wrong. I should have called this current account. Okay. So yeah, the name of the constructor must match the name of the class. So if you look at this new data type, current account 2, it looks much smaller. This is what inheritance will allow you to do. You only change the stuff that will change, and everything else will remain just as it is. You don't have to do any of that. That's a really nice benefit. Okay. So we're going to fix our code. We're going to create this current account 2. We're going to create this class, and we're going to create it in such a way that we can reuse our code. Whatever we have written will be automatically copied over. So let us go back and see how this is done. From the bank account, we create a new type. So let us try. Right from the scratch, we're going to create a new Java class. I hit Control-N, or you could also go File, New File. It's the same thing. We are going to create this Java class. And right in here, what I wanted to do is to create this current account 2, because current account already exists. And that's a bad name. Nevertheless, let us do that. So this current account 2, this is actually a subclass of bank account. Let me write these names down. This is called the base class. This is also called the super class. Okay, and this one over here is called the derived class or the subclass. Okay, so it goes in pairs. Either you call them base class or derived class, or you call them super class and subclass. That's how the name goes. Now, right over here, how do we say that a class is derived from something else? We say that this is extended from, so you say extends bank account. And as soon as you do that, you'd have to create a constructor for it. So you can click over here and say add constructor. Okay, that's a very convenient way to do that, or you could write it by yourself. Okay. So let's see how this is done. It calls the super method, and the super method means that you go to the super class and call the constructor. Super, just the word itself, refers to the super class. Since we're not naming any method, it means that you go and call the constructor. So let us have a quick look at what this is. Again, I'm going to use the feature of NetBeans. So if you highlight any method, you can right click and say navigate, go to source, or Ctrl+Shift+B. It will take you to the declaration of that method, exactly how that's written. So you see that we go to the parent class, and this is where we have the constructor, right? So this is going to be constructed that way. Is this part clear? Now, with that in place, we can now create a new type, say current account 2. That's our new type. And let us create B5 equal to new current account 2. And this is where we can supply some parameters. We need a user ID, right? And then we need a name. I'm creating an account for all our teachers. It's just that I don't know where he lives. Whatever. And let's say he created a bank account. Just a bit. Sorry, time for that little break I needed. I'll go and meet that guy, and I'll be right back as soon as I can. And while I'm gone, I'll just pause this video. Sorry about the delay. Can one of you help me turn that off? Thanks. Okay, so we're back. So like we got this new data type created. This is our current account 2. And we can create this account. This line is missing a semicolon now, that's right. So we got this new object, B5. We can perform some operations, like you can say B5.withdraw. Let us withdraw 1,000 taka from here. And then we can finally print this thing. So if you run this code, you'd see that we have some output for the newly created account. And we started with 5,000 taka. If you withdraw 1,000 taka, definitely you'd have 4,000 taka left. That's how it behaves. Okay. If you look at the amount of code that we wrote for this, it's just this part. So we have created a new data type with very minimal effort and very little change. So far, the only thing that we did is just writing a constructor, which in turn calls the base classes constructor. So, what's that? Yeah, we're recording, yes. It's that red dot right there. So it's recorded. But thanks. Sometimes I forget. So we are just calling this constructor. The problem though is that it still does exactly the same thing. It does nothing different, right? The idea for this current account, as you may see in this class, is the withdraw method needs to be different. That every time you withdraw some money, listen out, you need to deduct 15 taka extra. Is that clear? So this is something we were not able to address over here, and for that we have to make some changes. So what we want to do here is we want to redefine our withdraw method. Public Boolean withdraw. And this is where we pass how much money I want to withdraw. Let's say, let's have a look at this method. Withdraw takes long amount, and we are going to redefine this thing. Okay, it's the same method, it's just that we want to redefine this because it's going to behave differently. We're going to subtract extra money because withdraw is supposed to be an operation you don't want to do on a bank account, at least from the bank's perspective. Okay, now how do we mark that this is something that we are redeclaring? We do so by something called an annotation. This is an annotation. Annotations start with an @ sign, and this one just says override because we have a default rule for withdraw. We are redefining that rule. That's called overriding. Okay. If you notice, we have bank account class. That's the superclass, and it already has a withdraw method, right? But we're changing this thing over here. That's why we mark it with override, saying that we're overriding the rules. It's a new withdraw method. That's what the annotation does. Okay. Now is the turn for us to write the method, and for this purpose, I'm going to copy paste this because that's what we have written before. This is the withdraw method that deducts 15 taka extra if it is a current account. Okay, this is the current account class. So we wrote this thing before, but we have to write the whole thing. This time around, we won't have to. If you just bring it over here, and we are copy pasting this part. So that's exactly what it is. So if you look at this entire class, I know we got a compiler, we're going to fix that in a bit. So the way it stands now is that it's a really short piece of code from here to there. It's just 28 lines. And if you look at the previous example, which does exactly the same thing in the current account class, we have like 72 lines. So our 28 line of code is equivalent to that 72 lines of code. So that means that we have saved a lot of coding effort. I'm not saying that coding this thing was difficult because we pretty much copy pasted everything. But the problem with copy pasting is that it doesn't get out of data. If you make some changes in the base class, you have to make the changes again. Whereas if I make some changes now in the base class, it will get auto-reflected over here. And that's the real benefit. So before we go any further, let us explore why this thing doesn't work. We got a compiler, and NetBeans does a really good job at highlighting the compilers. Like right, you can see over here in the Project Explorer that we have a compiler right here in this file. So if you go to this file, the current account 2, it shows you the compiler right here. I didn't hit compile, I didn't hit build. It does the compilation as we go, right? As you write some new code, it readily compiles that and finds these errors. So balance over here, it has an error over here. And as you're learning this new language, Java language, you need to be really good at understanding all these errors. So let us take our cursor over here and see what it says. If you take your cursor over here, It says balance has private access in bank account. Okay. So if you go into the bank account class, this is the problem. This balance is marked as a private member. These private, public, these things are called access modifiers. So this is marked as private, so it means that only this bank account class has access to this, and no one else has access to this. Okay? So we need to understand this part, that since this balance is private, the subclass current account 2 cannot access this. So what can be the fix then? We can make this public. So as soon as you make this public, if you go to this current account 2 and let us save all the files, you see that the error goes away. Is this thing clear? Now if you run this project, you see that previously we showed that we had a 4,000 taka balance. Now it shows 3985, so that means that you're subtracting 50 taka extra. Okay, so this is working now with very minimal effort. We wrote very few lines of code to get this thing up and running. Is this part clear? That's the beauty of inheritance. Through inheritance, we can reuse our code, and we really have to write less. Another thing I want to show you, let us say I make some changes to the bank account class. Let's say we got withdraw, we got deposit, we got print, all these methods, right? So let me make a small change. I want to, let's say, print all these labels, ID, name, address. I want to print them in uppercase so that they stand out. Okay, so I made this change where? What class is this? This is our bank account class, right? I made this change, and I'm going to run this project, and I want you to notice where the changes took place. So over here, and the last one. Incidentally, if you look at the demo from where these things are called, we have B1, B2, B3, B4, and B5. We're calling print method on all these things. So if you notice, B1 and B2, they are bank accounts, and B5 is a current account 2. So I made a change in bank account, but that also worked for current account 2. Why is that? The answer is over here. Because current account 2 is extending the base class bank account. So whatever you have, all these public methods and everything that you don't override, this withdraw method is something you're rewriting. Okay, so this is new. But all these things that you're not overriding, they're copied just as they are. You're inheriting from them. That's why you don't have to rewrite them. Anything that you change in the base class will be automatically changed over here. And that's the beauty of inheritance, that you have to write less. Is this part clear? So let us address a real problem now, because what we did, in order to write the withdraw method, we made a fundamental change in the bank account type. We changed this thing to public. This balance was made public. If you'd remember, if you go back to bank account, we had to make this public. Why? Because otherwise the code doesn't compile. Okay? It's just in our...
Any other way?
Yeah, there has to be another way, because this is a really bad practice. Just in our previous class, we were talking about this encapsulation thing, how great it is. It keeps our data secure, and we are totally ruining this thing. And let me show you how bad this is. If you go to the demo now, let's say we do all these withdraw, we do all these deposit, but none of this should matter anymore, because now we have all the freedom to say the balance is going to be, let's say, 1 million taka. So I can just do that, right? I can do it for 1, 2, and 2. I can do it also for bank account number 5. So, so if you look at their balances, I can change them as I want. If it goes for B3 though, I can copy paste, I think. So for B3, if I try to make that change, that doesn't happen. Why? Because B3 is a current account, and if you look at the declaration of that, balance over here is private. So that was the essence, that you're supposed to keep these things private, right? So that no one can change them as they want. But we are changing that into public for our convenience, and now that's gone. So that's a problem. The solution is somewhere in the middle. So you can't do private because this class then cannot change this. You cannot do public because then everyone can change it. So what's the middle ground? The middle ground is protected. So this one over here is protected, and the symbol for protected over here is a hash sign or a pound sign, whatever you call it. Minus for private, plus for public, and this hash sign for protected. So what we are supposed to write, right in here in the bank account, that's where things are coming from. We're supposed to write protected. Okay, so that's the thing. If you write it protected, then you can also change it in the current account too. However, the problem still remains. It is, if you look at the demo, we can still make all these changes. In bank account 1, 2, and 5, we can still make the changes. So if you ask me what did we fix, at this point we fixed nothing. It's still the same problem. Right? Because for bank account 3, this is what we want to see, right? It doesn't work anymore. But even with protected, we are still in the same problem. We can't make these changes. We can make these changes because the way protected is defined in Java, which is a bit different than it is done in C++. In C++, the idea is that for private, only the current class has access. For public, everyone has access. For protected, the idea is that this class and all its subclass will have access. That's C++. It's not the same as Java. In Java, what happens is that every class that is kept in the same package will have access to protected members. So all these classes, bank account demo, credit card, current account 2, they're all in the same package. This bank.account.demo, that is the name of the package, and in Java, you write the name of the package in the very first line. Right up here, you're declaring that all these files, they have to be in this particular package. So if they're in the same package, and they're marked either public or protected, then everyone will have access, given that they're in the same package. So what is the fix? The clue is right there. What you need to do is you have to create a new package here. Let's say we are going to create a new package called it account, and all our account related classes, they will be kept right here. See, that's a blank package. How did I create that? Right click, new Java package. Okay, so what is the next step? We're going to take this file and put it over there, and here it says refactor, which is a shorthand. If you place it over there, you see that the name of the package changes over here. See, for other classes, if you look at any other class, it would say package bank.account.demo. That is the name, right? For this class, it says package account. So when you drag and put any class like this, this is where you have to refactor. What is refactoring? It's changing the variables, changing the package names and everything. It does so automatically. So current account, I want to place that over here because that's an account type. And current account 2, I want to place that over there as well. Okay, so right now, if you notice, this is what we wanted to see. That you can no longer change these things anymore. So now that works. Is this thing clear? So what was the problem in Java, the way it is defined? All the classes in the same package has access to protected members. Okay, that's why if you move this demo thing in a different package, it no longer has access to the protected member, so it cannot set the balance of each and every account to 1 million taka. It has to go through proper withdraw method, proper deposit method. It has to work like that. Okay, so that's one very important thing to understand, that in Java, protected means that all the classes in the same package would have access. And another thing, current account 2, this is extending bank account, so this is a subclass of bank account, right? Even if you move it to a different package, it would still have access to balance. So any subclass, if any subclass comes from a different package, that doesn't matter, it would still have access to the protected members. Otherwise, all the classes in the same package, they will have access to the protected members. So two things, and that's how you define protected. Let me summarize, let me reiterate this thing. Public means everyone will access. And let me write them down. Oh, why am I being lazy? So this is where I draw the summary. We're talking about access modifiers. Public means every class will have access to that member. By member, I mean it can be attribute or it can be operation. Okay, so every class will have access there. Private means only the owner class will have access to that member. So that's the thing. So when we had this balance set to be private, we couldn't we couldn't modify that in current account 2. That was a problem, so we had to change that. So this is public and private. Okay, so two things. All the classes in the same package will have access to that member. A protected member, I mean. And additionally, and subclasses, no matter where they belong, be it the same package or in a different package, they will also have access to the member. So this is the scenario that we have a balanced data member set it to be protected. Now, no matter where you place this current account to class, be it in the same package or a different package, it will always have access to the balance attribute. And all the other classes that are in the same package as the bank account, they will also have access to the balance. That's why creating the right package and putting the right classes in the proper way, it's going to be very important. So all the related classes, Since we're talking about account-related package, the idea or the convention is put them together. Okay. So savings account, current account, credit card, all these things, they have to be in the same place, and we put them in this account package. Is this thing clear? Okay, so that is to summarize. Let me save this thing. This is about the access modifiers. We're talking about encapsulation here, but the main concept that we covered today is inheritance. Okay, so these three things are already taken care of. When you go back home, please study chapter 1 and 2, mainly from Head First Java. Usually covers all these topics. Right? And we have a quiz coming up in our next lab class. That's where you have to study them anyway. So please do that. So I'm going to save everything and upload the code and also upload video. Do you guys have any questions about everything that we covered here? Did you guys sign the attendance sheet? All right, so that's it then.